Hello everyone, welcome to today's video where we'll look at how to make a RAG app with Ollama, LangChain and ChromaDB part 1. The first two parts of the video is for those people that are using a version of Python like Python 3.13 which may not work properly to install ChromaDB when we use pip install ChromaDB. The first part is basically about installing a Python 3.10 as an alternate Python environment, and then we will use this Python 3.10 to make the Python virtual environment instead of using the system default Python. After that, we'll install the required packages. Then we'll download the embedding model of nomic-embed-text and install the VS Code SQLite extension. Then we'll show you the code to split documents into chunks, code to add the embeddings to the ChromaDB vector database, and also the code to query the vector database based on the prompt you give it to get the initial documents for context, and then use the LLM to generate the response from the context, which is basically a basic RAG app. Let's go to the web browser. For Python, we go to python.org. We go to downloads or release. We press Ctrl F to search for, and then we type 3.10.10 because that's the Python version that we want for this case anyway. We right click on this link, Python 3.10.10, select open link in new tab. Okay, so Python 3.10.10, we scroll down, we select Windows installer 64-bit recommended, we click on it, we should download it. I actually already downloaded this, so let's go to the download folder. So Python 3.10.10, let's double click on it to start the install. We are not going to add this python.exe to the path because this Python is an alternate version. The main Python version would be whatever you're using. So this Python 3.10.10 is only used if you have issues with installing certain pip packages. In this case, the pip package for ChromaDB doesn't seem to work properly with Python 3.13. So we're going to use Python 3.10.10. Okay, then let's click on customize installation. Leave this all as default and click next. Leave this as default. Yes, we're going to change the customize install location. We will make it simpler. It will be in C drive, programs, Python 3.10. Let's click install. Okay, so setup was successful. So click close. Okay, now we're gonna go to C drive. We're gonna right click on empty space in C drive, select new folder, call this new folder rag_app. Let's go in. We click on the location field and press backspace to delete everything, then press CMD for command and press enter to open a command prompt in that folder, C drive rag_app. Let's press Windows right to move it to the right. Okay, we're gonna use the Python alternate Python environment that we created before to make this Python virtual environment. So let's go to C drive, programs, Python 3.10. Okay, this python.exe here. We select this location, the text in the location field. We right click, copy. We go back to command prompt. We right click to paste, then slash Python. Okay, then slash m, and we type env.env. Press enter to create the Python virtual environment using the alternate Python environment that we installed previously, the Python 3.10. So now if I type Python version before I activate the Python virtual environment, it will show the system Python version, which in this case is 3.13. So if I activate the Python virtual environment by typing .env /activate.embed, press enter, you see it's activated because there's the .env, that means the name of the folder name for which the Python virtual environment install is now in brackets besides the prompt, indicating that the Python virtual environment is activated. If I now type Python --, version and press enter, it will show Python 3.10.10 because I created the Python virtual environment using the alternate Python environment that I installed here. C drive programs, Python 3.10. Okay, now we're gonna install the pip packages that we need after we have already made sure that we're activated the Python virtual environment with Python version of 3.10.10. So we type pip install Ollama, LangChain community, pypdf, sentence transformers, and ChromaDB, and then press enter. Then we just let it install. So it's finished installed. If you get this issue, it should not be an issue. If you want, you could run the update by typing python -m pip install -upgrade pip, but for now you don't really need to. Now let's go back to the web browser, open a new tab, we search for Ollama, press enter, we go to click on models, let's search for nomic. Okay, so we want this nomic-embed-text. Let's click on it. So we're gonna download the nomic-embed-text, which is about 274 megabytes as shown here. Let's go back to the command prompt. We right click here, we enter the Ollama pool nomic-embed-text. Actually, before that, let's type Ollama list. You can see that we already have Llama 3.2, but we don't have the nomic-embed model. So when we right click, type Ollama pool nomic-embed-text, press enter, we will download this nomic-embed-text, which is what we're going to use to embed the text into our vector database, which is quite important, this embedding model. If you have not downloaded and installed Ollama yet, and if you have not downloaded the Llama 3.2 after that model yet, then I will provide a link to a tutorial that shows how to download and install Ollama, and also download the Llama 3.2 large language model. Okay, let's type code dot, then press enter to open VS Code in this folder. Let's click close. Let's go to the extensions, click extensions. Let's search for sqlite. We will use Florent Kempler. Install this by Florent Kempler, the SQLite viewer. Let's install. Click on Trust Publisher install. And now it's been installed. Let's close this. Let's go back to the Explorer. Okay, now let's go to View, and we go to Terminal. Then we don't want PowerShell, so let's click on the drop down beside it, and we select Command Prompt. So you see the command prompt is with the Python virtual environment activated. So we don't need this PowerShell. We can hover over this PowerShell and then click on the trash bin to delete this PowerShell prompt. We just want to use the command prompt. Okay, now let's go to Rec app. We go to new file, click a new file, we type rec_console.py, then press enter. Then I'll just paste in a code. Okay, this code. Okay, so we have argparse, ppprint, LangChain community, and LangChain text splitters. So what we're going to do, we're going to first split. Okay, so what we're going to do, we're going to first load the documents. We're going to load documents at a specific path. So we're going to have a documents folder. So let's go to here, let's click new folder, let's call it documents, and press enter. Okay, so we will have a load documents, and then we'll split the documents. So we'll split the documents using recursive character text splitter, which is under LangChain text splitters. So the chunk size will be 800, while the chunk overlap will be 100. So basically, it will split the text up into chunks of 800 characters, about 800 characters wide, with overlap about 100 characters between the different chunks. Okay, then you return this list of documents, list of text. Return this list of text. So they basically return the chunks back. So I'll have argpass to make it easier to process command line arguments. So -p or -- process docs will have a value of true if I use this flag. If I don't use this flag, then the default value will be false. I will also have a set underscore collection, which will be able to take a string value, which will indicate the subfolder of documents to be processed. By default, the subfolder will be small underscore world. So let me get this document, small world. Let's go to the browser, open new tab. Let's search for small world, days of wonder, small world. Yeah, days of wonder, small world. Let's click on it. Okay, actually I don't want the universe one, I want small world, just small world, not the universe one. Then I'll click on download the rules and click on English. Okay, then let's go to the download folder. Edit thing. Okay, let's press Ctrl S to downloads, to save the download. And then let's go to the downloads folder. Yes, so it's there. We go, let's select this, press Ctrl X to cut this, and let's go back to Visual Studio. Let's go to documents, right click on it, select another folder, new folder, type small world here, press enter, then right click. We're gonna just paste, Control V to paste the small world file that I cut just now. Let's just close this. Okay, let's type Python right underscore console and press enter. So you show is false, default value is small underscore world. So path documents will be documents. The path underscore documents base is actually documents, and the collection name current will be small world. So that's why path documents is document slash small world. Document slash small world. Okay, let's put -h, then press enter. -h is basically like help. So I want to process this document. So if I select -p, which will then process the files in documents folder, specifically process the file in the documents folder, specifically under, in this case, small underscore world folder. So basically it process this PDF file. So what it does, it will load the document. It will, under path documents, it will be documents underscore small world will be passed to load underscore documents, which will then use py PDF directory loader to load all the files inside, all PDF files inside this folder, documents slash small world. And then you return this, and then you store this inside documents, and then you then we pass these documents into split underscore documents, which will then use the recursive character text splitter to, like I said before, split the documents into chunks of about 800 characters. In each chunk of about 800 characters with overlap of about 100 characters. So let's press enter to process it, and then it will print out, and then you return these chunks, and I'll use ppprint to print out these chunks with indentation of 4. So we see it's broken up into into documents, about 800 characters in size each. Okay, now let's scroll up. Let's go to here and let's put in some new code. We put in 2 new functions. One is called getVectorCollection, the other is addToVectorCollection. So the getVectorCollection, we will pass in the collection name. So in this case, the collection name would be the name of this small, at least for my case, I'm going to use the name of the subfolder, in this case small_world. Then we will also use the nomic-embed-text, which I told you to download previously from Ollama. So if I type Ollama list, I can see the nomic-embed-text is there. Okay, let me type CLS to clear. Okay, then so for this, then after that, we make the embedding function, and then we pass this embedding function to the, okay, then I think we will make the ChromaDB here using the path of Chroma. So basically a folder called Chroma will be created, and then the SQLite file, which will actually contain the ChromaDB, will then be created inside that. So the collection name would be, like I said, in this case, would be small_world, using the embedding function, which is very important, using the nomic-embed-text. This one, you just use it for now. Okay, though we can actually change this to different things like cosine and other things. But for now, you just know that the collection name and the embedding function is important. And then after that, we will pass. Okay, so before that, let's import ChromaDB. Import ChromaDB, save. So that is now there. Then we're going to import the Ollama embedding function. So from ChromaDB dot utils dot embedding functions import Ollama embedding function import Ollama embedding function. Yeah, save. Don't worry, this code will be given to you, so you don't have to memorize this. Okay, so actually the most important function is the addToVectorCollection, which we will pass in the collection name. Like I said, it's in this case it will be small_world. We will also pass in the chunks. The chunks are basically what is written by the split document. Then we will use the getVector function to get the appropriate collection based on the collection name. And then we will run through the different chunks. We'll get the source for the chunk and then get page for the chunk. Based on this, we will determine the source :page to create a current page ID. So if current page ID equals to the last page ID, then there's no change. Then we'll just increment the current chunk index. If the current page ID is not equal to the last page ID, then we set the current chunk index back to 0. So this is also that we can create the appropriate chunk ID based on the current page ID and the current chunk ID. So when we go to the next page, the chunk index will reset back to 0, because a page could have multiple chunks of data. Yeah. So documents will append the page content of each chunk, and metadata will also append the metadata for that chunk. Then we'll append the chunk ID, which is based on the current page ID and the current chunk index. Then we will insert or upsert this into the collection, basically put in that data inside to the database inside the collection called small_world in this case. So with the appropriate documents, metadata, and IDs. So what we do is this. We are going to use this. We will chunks is there, collection name current, yeah, collection name current is there. Then yeah, okay, fine. Let's save this. Then we type Python console. Let's enter. You want to go in here because process dot is false. So we need to make it process the document. So let's say we use Python space rec_console.py, then put -p to process the document. So we load the chunk. So let's say it will create a folder called Chroma because the path Chroma is there. So path Chroma and create folder called Chroma, and then inside you will put the actually add the sqlite file inside, which will store the embeddings. So the embeddings are basically the chunks that we created using the split document. Then we embed them appropriately using the appropriate embedding model, in this case nomic-embed-text. You can use other models, but I'm using the nomic-embed-text. So if I click on this, because I installed the extension just now, so I can see this. I can see the collection is small_world. I see the full text search. There's 51 chunks. If I go to embeddings, you see, yeah, 51 chunks here. So this page 0 of chunk 0, page 0 chunk 1, page 0 chunk, page 1 chunk 0, page 1 chunk 1, page 1 chunk 2, page 1 chunk 3. So let's close this. Let's type CLS here. And let's go in here. Let's paste in some more new code. Okay, so basically I've added 3 functions. One is query collection, one is generate context, the one is call_LLM. I've also added this part. So while it's true, that means an infinite loop. User query will input, that means ask for input from the human, which is me. If I input the value done, then it will just exit this infinite loop. Then result. So you query the collection using the collection name, and then you pass the question that the human asks. Then from that we get results. Then we get the first document of, we get documents, and then we get the first element. We pass it to generate context. So okay, let's look at the query collection first. So query collection is just get the vector collection using the given collection name. In this case will be small world. And then you will query and then also pass in the prompt, query text, pass in the prompt, that means the question. The results would be 10, so you want the 10 documents that we believe most related or to this query. then we will, so these documents return back as results. So we get the first element of the result, pass it to generate context. Generate context will get this list of documents. We'll iterate through the list of documents and we'll add each document to the context, then return this context. Basically, it will concatenate all the list of documents or list of strings and then concatenate it into one big string, which will take it as the context. So we return the context. So this context will then be passed to core_lm. So context passed to it with the user query, the value equals prompt. So you call lm. So for each chunk, so you call lm. So call lm, basically you'll use Ollama chat. We want it to stream. We use the Llama 3.2 model. So like you get Ollama list, you can see the Llama 3.2 model here. So we pass it messages, which is an array, sorry, a list. So in this list we have two different tuples. One tuple will have the key row system, another key content, which will be based on the system prompt, which I added here. Okay, system prompt. So we tell the system, or in this case the LM, that it's an AI assistant tasked with providing answers based solely on a given context. And the context will be passed as context, and user question will be passed as question. We want it to answer the question, we tell it to analyze the context, and then this tells it how to answer the question, and this tells it how we want it to format the response. And again, we emphasize that the response should be based solely on the information provided in the context. So this is the system prompt. Then we also have the user. So user will have context : given context. So the context is actually the concatenation of all the list of documents that is passed to it when we do the query, when we query the collection. So based on that context and the question which is passing as prompt, we pass to LLM, we ask the LLM to generate the appropriate response, and we want to stream this. So because we want to stream this, so basically it will be for each chunk in the response. If it's done, if chunk done is false, that means it's not reached the last chunk yet, then it will yield the chunk, the message content. If it's reached the last chunk, then it will just stop. So this generator basically that's why we have to do this for chunk in core LLM, which will then, this is how we handle streaming. So we put comma n equals to empty string chunk, comma print out the chunk, comma n equals to empty string. So using this, we can stream the output even in console. So let's try Python rank _console, press enter. Oh, sorry, we should save it. Control S to save, and we press then Python rep. Okay, so now human, we ask it. Okay, let's look at the document. Let's ask it how to set up the game. Okay, let's ask it how to set up the game. How do you set up for the game? Sorry, my apologies. Got to import Ollama. So we need to import Ollama and save. Control S to save. Let's try this again. Python rec_console.py. How do you set up the game of small world? Press enter. So it tells you to set up, you follow the steps, choose a map, matches the number of players, place the chosen map in the center. Okay, so let's check. Pick small world map, place the game term marker. Yeah, it looks about right. Congratulations for coding your own Rag app. The upcoming video will show tips to improve the Rag app, such as using cross-encoder to re-rank the retrieved documents to improve the quality of the context, which should also improve the response generated, and how you can process documents in different subfolders into different collections in ChromaDB. If you learned something useful, please hit the like button. If you want more videos like this, hit the subscribe button. See you in the next video.